Hey guys, Mr. Rast here, and I'm going to go over the Topic 9 Stoichiometry practice problem. You should be able to answer a question like this for the test. This is pretty much the point of Topic 9, to be able to answer questions like this. There might be multiple questions like this on the test, so let's get started. There's a link to this question on the webpage if you need a copy of it, but otherwise, let's just work this out, and hopefully you gave it a try before you're watching this video. So the question is, first of all, I've got this problem here, and it says the first part of it is we need to balance the equation. We need to balance the equation here. So to do this, let's take a look. I've got carbon, hydrogen, and oxygen. Those are the different reactants I have here, and products. I've got 6 carbons and 14 hydrogens and 2 oxygens on my reactant side. On my product side, I have 1 carbon, 2 hydrogens, and 2 oxygens, and another one. I've got 3 oxygens here. Now, the technique that I like to do with this is to always balance the elements that I can find alone last, such as oxygen here, it's alone, because anything else that you balance, it will change another value. So let's do the oxygen last. So let's just start with carbon. We've got 6 carbons here, but you get 6 carbons on this side. If I put a 6 here, now that gives me 6 carbons, but it also gives me 12 oxygens plus another 1, so that's 13 oxygens. Okay, let's try the hydrogen. I've got 14 on this side, so to get 14 on my product side, it's a multiple of 2. If I put a 7 here, that will give me 14 hydrogens, and now I have 7 plus 12. I've got 12 oxygens here and another 7, so that would be 19. 19 oxygens. Let me just double check. 12 and 7, 19. Yeah. Okay, so everything's balanced except for my oxygens. So 2, this is a multiple of 2. 2 goes into 19. That's the question I want to ask myself here. And that would be 9.5, right? 9.5, because 9 times 9, or 9 times 2 is 18. So 9.5 times 2 is 19. Now, I don't want to leave things as decimal points, so to make it a whole number, if I multiply everything through by 2, it'll turn everything into whole numbers. So I'm going to put a 2 here. 9.5 times 2 would be 19. 7 times 2 would be 14, and 6 times 2 would be 12. So we have a 2, this is a 19, a 2, 19, 14, and 12. So you can see that there. Now it's balanced. The next question is, it's just a series of 4 questions. The questions are, how much hexane do I have left over if I react 0.12 grams of hexane with 0.69 grams of oxygen? So this is the question, and it's asking how much hexane is going to be left over, how much oxygen, how much water is going to be produced, and how much carbon dioxide. Well, this is a limiting reactant problem. If I've got both hexane and oxygen, one of these guys is going to run out first. Is it the hexane that's going to run out first, or the oxygen that's going to run out first? And I don't know this yet by these numbers. So how you figure out which one's going to run out first is convert one of them into the other. So I'm going to convert grams of hexane into grams of oxygen and see if I have enough oxygen or not to burn up all the hexane. So I'm going to do this at the very bottom of my paper. I'm going to actually, this first step is just to figure out what my limiting reactant is. So it says here that I've got 0.21 grams of hexane, which is C6H14. If I've got this much hexane, I'm going to convert these grams into moles. To do this, using the periodic table, I'm going to add up 14 hydrogens. So hydrogen is 1.008. Hydrogen 1.008 times 14 of them. So this is going to be the hydrogens, 14 hydrogens. 14 hydrogens equals 14.001 grams per mole. And let's also add up 6 carbons. So carbon is here 12.011. 12.011 times, and we have hexane as 6. So in the carbons, for the carbon alone, I have 6 carbons is 72.066 grams per mole. And so together, I'm going to just take that number and add the 14.114 to it. So hexane has a molar mass of 86.180 grams per mole. That's the molar mass of it. So I'm going to put this over here to cancel out the grams. 86.108 grams per mole, and this is hexane. Grams of hexane cancel for 1 mole. And now I'm going to use the balance equation. The relationship between hexane and oxygen is 2 to 19. It's a 2 to 19 ratio. So for every 2 moles of hexane, there's 19 moles of oxygen. And now I want to convert moles of oxygen into the mass of oxygen. So oxygen O2 is 15.999 times 2 because O2. So the molar mass of oxygen would be 31.998 grams of oxygen per 1 mole of oxygen. Moles of hexane cancel out, moles of oxygen cancel out, and then grams of oxygen. So this is telling me that if I use 0.12 grams of hexane, how many grams of oxygen are needed. So I'm going to run this in the calculator right now. And right there. 0.21 divided by 86.18 times 19 divided by 2 times 31.998. And so it's saying to use up all that hexane, I would need 0.741, rounding off significant figures, grams of oxygen. So to burn up all of this, I need this much oxygen. I need 0.714 grams of oxygen. Do I have that much oxygen in the question? I have 0.69 grams of oxygen. So I don't have enough oxygen. I don't have enough oxygen to burn up all of my hexane. I need more oxygen than I actually have. So therefore I just discovered something. I just discovered that the oxygen will run out first. So because I know oxygen is going to run out first, this second question here is, what is the mass of oxygen in grams when this is over? And that will be 0 grams. This is my limiting reactant. So I will have some hexane left over. That will be in excess. How much hexane is left over? Well, it's determined on how much, when the oxygen runs out, how much hexane will it burn. So let's figure that out. We're going to convert our oxygen into grams of hexane. Basically what we just did, kind of in reverse. So 0.69 grams of O2 times, we just determined that the molar mass of oxygen was this right here, 31.998. So 31.998 grams of O2 per 1 mole of O2. And the ratio between oxygen and butane or hexane is there are 19 moles of oxygen for every 2 moles of hexane. And we already determined the molar mass. We already determined the molar mass of hexane. So we can use that again. For every 1 mole of hexane, there is 86.180 grams of hexane. Okay? And that will tell us how much hexane is needed to use up all that oxygen. So we would put 0.69 divided by 31.998 times 2 divided by 19 times 86.18. So to burn all this up, it would need 0.1956 grams of hexane. It would need this much hexane to burn up all of our oxygen. And we have more hexane than that's going to be, so it needs this much, and we have more than we need. So if we start with this is what we had. That's what we had. That's an H. And this is what we used. So if we subtract the two, we'll get what's left over. So we're going to take 0.21 minus 0.1956. And so left over, I've got 0.014, which two significant figures. We can just leave it like that. Grams of hexane. So that would be our answer. So we're done with 2 questions now. We know how much hexane is left over. We know that there's no oxygen left over. Now we're going to determine how much water is produced. Well, we're going to use the same value here. The oxygen is what's driving this reaction, the numbers, because the oxygen ran out first. So we're going to do the same exact thing, except up to here, when we get to this point here, it's not going to be moles of oxygen to hexane. We're going to do moles of oxygen to water, and then the molar mass of water here. So it's almost the same setup. Once you start rolling, it actually gets a little bit faster because you have the kind of setup already done for you. So let's do this to water. 0.69 grams of oxygen for every, there's 31.998 grams of oxygen for 1 mole of oxygen, and that's, we already did that. And there's 19 moles of oxygen in that balanced equation for every 14 moles of water. The molar mass of water would be 2 hydrogens, which is over there, 1.009 times 2 plus 1 oxygen, which is 15.999, and that's our molar mass of water. For every 1 mole of water, I don't know if you guys heard the school announcement or not there. Anyways, this is our molar mass of water. Grams of water cancel, moles of oxygen cancel, moles of water cancel. We're in grams of water. So we'll string that number together. 0.69 divided by 31.998 times 14 divided by 19 times 18.015. So we are going to be producing 0.286, I'm going to round that up, 29 grams of water. So 0.29 grams of water is being produced by this setup here. And the final part of it is to figure out how much carbon dioxide is produced. So to do that, same setup, our oxygen will drive this reaction. We'll determine all of our products and reactants that are left over, which is oxygen. So we're going to set it up just like we were. (19 moles of O2). See, I took grams of O2 into moles of O2, and now I'm going to convert that into moles of carbon dioxide. And then we are going to say that carbon dioxide, for every 1 mole of CO2, there is the molar mass of carbon dioxide would be oxygen 15.99 times 2 plus a carbon, which is 12.011. So our molar mass of carbon dioxide is 43.991 grams of CO2. Grams of oxygen cancel, moles of oxygen cancel, moles of carbon dioxide cancel. I'm in now grams of carbon dioxide. So let's try this one. 0.69 divided by 31.998 times 12 divided by 19 times 43.991. And we come up with 0.599. So that would round this up 99. That would round this up. So 0.60 grams CO2. Now there's some rounding issues here, but that's okay. So to double check my work, that's my answer now. I've got all of my values for all my reactants and products. Just to double check your work real quick, a good thing to do if you've gone through all this work is take a look at what we started with. What we started with was 0.21 and 0.69. Remember the law of conservation of mass, that matter won't be created nor destroyed. So if we take these two numbers and just say 0.21 plus 0.69, we have roughly 0.9 grams. That's what we started with. If we take a look at what we end with, it should be the same number. And if it's not, then I probably did something wrong here. So let's take a look here. I've got the first number would be 0.014 plus oxygen is 0, so we don't need any oxygen. So I'm adding that to 0.29 plus 6. Oops, I have 0.6. I think you get the point, but let me do it anyways. 0.014 plus 0.29 plus 0.6, and that comes, all these added up together comes out to roughly 0.9 grams. So these two, that's what we started with, that's what we ended with. Good sign that we did it right. See how it compares to how you worked it out and what you got. So that is my final answers right here. 1, 2, 3, 4, and that's my balanced equation. So let me know what you got and how you came up with what you came up with, and save any questions for me next time I see you. Good luck, and we'll talk soon. Bye.